So here's an example of using a photocell with Triggy. So I have a light dependent resistor, which is what we call a photocell. It's connected to input number 2. By default, when these units ship, the channels are configured for certain types of signals just for convenience. Typically it's audio, photocell, and pressure for the first 3. The 4th is always trigger. The other 4, the configuration on your unit will depend on how it was configured for your purposes based on what we've discussed in advance. So for this example, I'll use the second input. It's already configured for a photocell. And you'll see that the photocell is connected and the photocell is on this screen of this low-end laptop. And if I have black in front of it or behind the photocell, this LED is off. And if I move it over this gray spot, just that change in luminance is enough to set off the trigger. So it's high as long as the input is above threshold, or it's in fact below threshold, as you'll see later, exceeding threshold. And it will be, of course, high based on a white input as well, because that's also brighter than the threshold that we've set. So let's try setting a threshold where the dark input does not meet the criteria, but the white does. So I'm just going to go over here to that channel. I'll go to threshold and I'll adjust a channel threshold. It's asking me which channel to use. I'm on channel 2, so I'm going to adjust this up to 2. And you can see the threshold now is set at 50%, so that's right in the middle of the range. If I keep adjusting this upward, then we'll be getting above that gray that's setting it off. And at some point, this LED will go off, and that will tell me that that threshold would be high enough that the gray won't set it off. So here at about 63.7%, the LED is off, and I'm above that. But what you'll see is if I drag it over the white, or I drag the white in front of the photocell, that is adequate to set the threshold off. So if you wanted it to, your experiment to have a gray background and bright white stimulus, you could set a threshold very uniquely for just the white and not gray. For our example, I'm just going to go ahead and bring this back down to 50%. On the black, 50% is suitable to turn it off, and it will also go on when it gets anything lighter than that, gray included. So in practical use, we don't want to so much measure the luminance of each of these spots on the screen. What we want is to detect the appearance of that. So if I were to present a stimulus that's light, it will send a trigger, and then it will go off when the stimulus disappears. So let's take an example of that. I'll start a presentation, and in presentation I have an experiment already selected. And if I just hit run, what we should see is that this illuminates each time the spot behind the photocell goes white. And you'll also notice that the trigger output is flickering each time a trigger is set. And there should be a trigger for each one of these changes. So in the oscilloscope software, I should be able to detect whether or not the change in the screen aligns with the trigger coming from the digital trigger port, which is the standard biosemi virtual serial port cable. So I'll leave this running, and then we'll switch over here to the oscilloscope screen. So in the oscilloscope screen, I have set channels 0 and 1 to capture the digital and analog copy of the signal coming from the photocell, respectively. So the orange trace is the analog, the red trace is the digital. And you'll see that as I mentioned before, the signal from the photocell is going below threshold, and that's when the trigger is set off. or set on, as it were. So what you'll see though, what's interesting is to know whether or not the two align precisely. So let's zoom in by decreasing the time base and just carefully inspect the relative timing of these two. So if I drag this down a little bit, you'll see there's a little bit of a time lag, probably because of an imperfect threshold. I can try adjusting the threshold a little bit to see if I can get it more precise, or I might be satisfied with it as it is. Let's just try reducing the threshold a bit. So you can see if I go too far, I'll be triggering on every change. There is another setting at play here. I'm going to set that value. And you'll notice that it's double triggering. So what I want to do is just change the duration as well, so that the duration is based on, so it's longer than the longest stimulus that will appear. So the duration of my output now is 710 milliseconds. When you see this signal going down and that one going up, that's the onset of the bright illumination of the stimulus on the screen.